Yeah, thank you for joining this new section. In this section, we are going to talk about network attack. And the network attack we are going to mention out is actually the denial of service attack. So we are going to go through exactly what is actually a denial of service attack and how this kind of attack can be performed. And also, we're going to go deep into what we call distributed denial of service attack. So we're going to illustrate, the process and see how it can, be implemented from a network perspective, but also from a software perspective with the implementation of smart contract. So, but now we're going to focus on the network side of it, okay? And we are going to have another section. We are going to talk about the software part of it, how it can be implemented in actually a smart contract. So with that being said, let's get started. Now we have a diagram here, and let me explain exactly what it is. Okay, this is actually a web server. Okay, let's say it's actually a web server, and here we have a hacker. Let's say it's not really a hacker for the first time. So if you want to, let's say, you want to buy a book on Amazon, you need to pass through the web server via what we call an address. And once you type the address of that web server, it's going to redirect you to the web page. Okay. Once you get into the web page, you can actually choose to buy the article that you want, the books that you want, or the clothes that you want, to buy an article. So this is actually the path you have to follow. So you have your computer, you type an address, and your address leads you to this, Amazon web server. Once you tap it, it's going to render you what we call a web page. Okay. Once you are getting to the web page, you can actually choose to buy your product or services, depending on what you want to buy. So this is actually how it works. So let's consider now we have a hacker or an attacker is willing to make these services enable. Okay. And yeah, because the denial of service attack is a kind of attack that make a service enable, okay, for a certain period of time. It can be forever. And the service here is actually getting into the web page and buy some articles. So it will make it impossible to happen again, maybe for some period of time or for forever. So it's really important to understand that. So the hacker is going to send what we call a huge number of packets per second. Yeah, I've called it like transaction per second, but it's not transaction per second. It's actually number of requests per second. So it's going to send a huge number of requests that this web server cannot actually handle, because this web server has been used for, like, let's say 100 requests per second. Over that, they cannot handle it. And this man is going to send like 1,000 requests per second, and it's going to make this server going down. And if the server goes down, it will not be able to render this web page again so that people can buy or not. So it will not be able for people, to buy some services on Amazon website, because this web server is actually under attack at what we call denial of service attack. So it is a kind of attack that makes a service enable so that customer cannot actually access this, this service. Okay. And it can cause million or even billion of losses in terms of, revenue, in terms of, profit, because if Amazon goes down for like, one day, you do not know what they can actually lose in terms of, sellings, in terms of money. It's really important, because every day and night people are actually buying services, buying products on, Amazon. And it's really important to understand that. So the send, it's actually going to send a huge amount of, requests per second, so that the server will go down and will not be able to render this web page again. So how come can these, hackers send more than 1,000, requests per second? So this is what we are going to see now. And this is what we call the distributed denial of service, because this hacker is going to be called the master hacker or the master chef. So what's going to do is that it's going to corrupt another computers around the internet. Okay, they are what we call a malware. So they are going to download the malware without even knowing that they have downloaded any malware or malicious malware. So this is actually how it works. So the master, hacker is going to corrupt other computers. So that once they connect to the internet and they download the malware without even knowing that they have downloaded the malware, they are going to, send some request to the web browser or to the web server, to this web server. So all these botnets, because they are called botnets, okay, they are going to send transaction. And imagine that this master has actually corrupted like thousands of machines around the world. So they are going to send requests to this web browser, and this Amazon web server is going to get down. And if it gets down, you see that the page is going to make like it's loading. It will not be able to, the client or a customer will not be able to get a specific, item that it really wants. So the service is unable. And this is actually a well-known attack around the space, around the IT space, around the network space. So this is actually how a distributed denial of service attack can be performed. Okay, so now we are going to move and understand how this kind of attack can be implemented in blockchain, and from a network perspective or a transaction perspective, and also from a software perspective like smart contracts. So thank you for joining this course, and see you in the next session. Yeah, thank you for joining this new session. In this session, we are going to talk about denial of service attack on a transaction perspective. Yeah, thank you for joining this new lecture and this new session. In this session, we are going to talk about denial of service attack and how it can actually take place on the blockchain. So we are going to talk about it from a transaction perspective. And now we've seen, how a denial of service attack can be operated on a traditional IT system. And we also saw about the distributed denial of service attack. Now we're going to dive deep into how this kind of attack can be launched in a blockchain network from a transaction perspective. So you need to understand exactly how transaction actually take place. It's true that we talked about it in the proof of work, but now we need to talk about it in this specific concept for you to be able to understand exactly how it works. So we have Alice here and we have Bob. So what you need to understand is that for a transaction to be validated into the blockchain by miners, it has to follow a certain path, okay? Once Alice sends a transaction on the blockchain, miners have to compete each other, as you know, to be able to validate the transaction. And once it is done, the transaction goes into the blockchain so that all the nodes can have a copy of that. But what you need to know is that in real time, there are many transactions that people are actually, sending over the network, so that once Alice actually sending transaction, there are other transactions that are actually waiting to be mined or to be, validated by miners. Okay. And all these, transaction goes into what we call the main pool or the transaction pool. This is the main pool or the transaction pool. So the main pool actually, has all the transactions that are not yet, been mined, or that are going to be mined or validated by the different nodes. It's really important to understand that. So imagine that Alice is sending, many transactions, let's say many transactions under a certain period of time, and Bob does the same thing, is actually sending many transactions under a certain period of time. What is going to happen is that all these transactions that they are actually sending is going to go to the main pool, okay? Because the blockchain cannot process all these transactions once. It's going to get into the main pool, and these transactions that you can see here are going to get into the main pool. Okay, these are the transactions. So the main pool is going to be saturated because Alice and Bob are going to send huge amount of transaction under a certain period of time, and it will cause the network congestion. So the network is going to be congested because there are many transactions, and all these transactions are going to get, into the main pool because they are yet to be mined. And once the main pool is saturated, what is going to happen is that it can cause, network latency because of too much transaction. So the node are going to work, twice or, 3 times like they used to, and it can cause also the, node crashing because the node is going to going over its real capacity. Okay, so the first thing it can cause is actually what we call the network, latency. All the nodes are going to be less performant because they'll have to, manage a huge number of transactions that they are not actually used to. And also the software itself, okay, the consensus algorithm software can crash too because it also has a certain amount of transaction that it cannot handle. So this is just an illustration, and that's what we call transaction floating. To implement a denial of service attack on blockchain, you need to understand that it has to pass through transaction floating because we flood the network with transaction, and all these transaction goes into the main pool. The main pool is actually the place where transactions that are yet to be mined stays. Okay, and once it is there, it's going to create, network latency. Is going to, ask to the nodes to, work more, and it can cause the nodes crashing down, and also the software running into each node, can crash because for some blockchain or for all the blockchain, there is certain limits of transaction that it can handle. Okay, per second. So it's really important to understand that. So thank you for listening to me, and see you in the next section. Yeah, thank you for joining this new lecture and this new session. In this session, we are continuing talking about denial of service attack, but we're going to focus on smart contract level. We're going to explain how this kind of attack can be carried out on a smart contract, but also how to prevent this kind of attack from a smart contract. In the previous lecture, we talked about denial of service attack from a transaction perspective that we call transaction floating in the blockchain, and we saw that this denial of service attack can actually impact the blockchain performance. We also talked about the denial of service attack from a network perspective, and we saw that we can also upgrade to the distributed denial of service attack, where we have both nets that are going to, send huge amount of packets to a particular server to crash down. Once we said that, we need to understand that a denial of service attack is a kind of attack that prevent, a server or a system to provide a service is actually supposed to. So it's really important to understand that. So in this example, from that smart contract example, we're going to see exactly what is the service that the smart contract provides and how this smart contract can run under such attack. So it's really important to understand that. With that being said, see you in the next section where we're going to start talking about the denial of service attack from a smart contract perspective.